Hey everyone, welcome to Shardeum's workshop for ETH India. My name is Greg Hemmer. I'm the head of ecosystem at Shardeum, an EVM-based layer 1 that scales linearly using dynamic state sharding. At Shardeum, we've noticed a challenge that existing blockchains don't scale. You have this upside-down J-curve where at first blockchains have a great user experience. They have low transaction fees that get processed quickly. But as these blockchains grow in popularity, they reach their scalability bottlenecks where they have more transactions being submitted to the network per second than the network can process, resulting in a queue of transactions that build up where users bid on gas fees to prioritize their transaction first, resulting in rising transaction fees. And our co-founder Nishal Shetty founded Shardeum as a result of experiencing this challenge firsthand while operating his exchange WazirX, where he noticed that users weren't withdrawing crypto like Bitcoin and Ethereum to the blockchain because transaction fees are too high. And so if we want to live in a world where decentralized applications go mainstream, we need to have blockchains that can scale linearly to keep transaction fees low while remaining decentralized, no matter how many transactions there are. That's exactly what Shardeum is building, an EVM-based layer 1 that scales linearly using dynamic state sharding. Dynamic state sharding is an architecture that shards the compute, network, and state, where each validator is assigned to a unique range of address space while retaining atomic composability. This enables TPS per validator, where Shardeum is the first blockchain in the world to increase its TPS relative to the number of validators in the network. Just like mainstream Web 2 applications, when you need more scale, you add more servers. The same goes for Shardeum. When you need more TPS, you add more validators. Shardeum retains decentralization using lightweight consensus mechanisms. We use proof of stake in proof of quorum, which translates to low hardware requirements to operate a validator node. It'll only ever cost $50 to $100 a month to rent a dedicated server to operate a Shardeum validator. And so because of these low costs, there's a high number of people in the world that can afford to operate a validator on Shardeum, enabling true decentralization. Shardeum is also a fully permissionless network where no permission is needed to run a validator. Anyone who wants to run a validator and has the required stake and the hardware needed can operate a validator on Shardeum. Shardeum is highly secure, in part due to a feature called node rotation, where every 60 seconds, some of the validator nodes waiting on standby in the Shardeum network join the network and replace a portion of validator nodes that are active in the Shardeum network. And so every 60 seconds, you get this swapping process that happens where some of the validators go to standby and some of the standby replace those validators. But no standby node can choose when it is added to the network or which shard it's added to. And this allows for true decentralization and high security. In contrast of a dynamic state sharded network like Shardeum, when we look at an unsharded blockchain, every validator in the network does the same work. Each validator is responsible for processing all of the addresses transactions in the network and storing all of the transaction history data. And so when you add more validators to an unsharded blockchain, we recognize that you only get more decentralization and redundancy. But it's our belief that eventually you have too much redundancy, and what you really want is parallel processing, so you can continue to scale and increase TPS, preventing congestion. And so if you look at the most popular way blockchains that are unsharded scale today, they scale vertically, where when they get congested, they use more powerful nodes to increase their throughput capacity. By using more powerful nodes, you're increasing the cost of the hardware needed to run a validator node, resulting in centralization because less and less people over time can afford this hardware to operate a node. Also, scaling vertically isn't really true scaling. It just makes the blockchain faster because it just incrementally delays the time it takes to run into your scalability bottlenecks that you were hitting previously. For example, when executing transactions, this happens at the CPU of a node. And if the blockchain is getting congested and reaching, nodes are hitting their CPU capacity, You can scale vertically and use more powerful computers with a more powerful CPU to execute these transactions faster. But as the demand of the network continues to grow, you're going to hit that CPU capacity bottleneck again. And so vertical scaling doesn't really mitigate the scalability bottlenecks that blockchains face. To mitigate these bottlenecks, we need to shard the blockchain and scale horizontally. This is the way that all Web 2 distributed systems scale, and this is how Web 3 distributed systems or blockchains will scale as well, using sharding. And so with Shardeum, we've built the most advanced sharded architecture that's been built in Web 3 to date, where, as I've mentioned, each validator covers a unique range of addresses and only needs to execute the transactions for the addresses it's assigned to and store the state for those addresses. And so here in this oversimplified diagram, you can see rather than every validator doing all of the work, you can complete work in parallel. And you may also notice that some of the validators, while they each have a unique range of addresses that they're assigned to, some validators also cover the same address. And so with Shardeum, each validator covers a unique range of address space while having a lot of overlap. And this overlap results in every address having the required redundancy of 128 validators. In addition to the benefit of linear scaling, Shardeum is also the first blockchain in the world to build auto-scaling, where here we have a simplified diagram of a Shardeum blockchain. Each black circle represents an active validator, and the white circles represent a standby validator node. This Shardeum blockchain is currently processing 750 TPS. And using the auto-scaling feature, every 60 seconds, Shardeum measures its load and comes to consensus on the required number of validators needed to process the current load. So as this Shardeum blockchain grows in popularity and applications acquire more users who are submitting more transactions, it's realizing that its load is approaching network capacity, and it comes to consensus on the fact that it needs to add more validators to process the current load. So it autonomously adds nodes from standby and activates them into an active validator state, resulting in an increase in throughput capacity to 1000 TPS. This is a simplified diagram of how Shardeum works and why Shardeum developers in our community are so excited about what we're building, because for the first time you have a blockchain that can increase or decrease its TPS autonomously relative to the load of the network. You might be thinking, why would any blockchain ever want to remove validators and decrease its TPS? Well, Shardeum prioritizes efficiency. It never wants to pay more node rewards than necessary to process the current load. So, if a black swan event happens or issues like some of the recent issues in Web3 occur and we go into a bear market and load on the Shardeum network reduces, it doesn't want to pay, say, 100,000 nodes, for example, if it only needs to process 20 TPS. And so it'll remove validators to the minimum number of validators needed to process the current demand. So it only needs to pay minimum node rewards at all time. One thing we're really excited about that we wanted to ensure could occur is that you have the same developer experience as building on an unsharded blockchain, where you have atomic composability with all contracts on the network, while also getting the benefit of linear scaling. So I'm really excited to say Shardeum has atomic composability in a sharded network. This means you can have things like DeFi, where you have an AMM with a router contract and different token pair contracts that are sharded, where these contracts live on different shards and nodes across the network, but those nodes can still retain atomic composability and execute the transaction in one transaction, where the contracts can have composability with each other and all other contracts on the network. As a developer, you no longer need to worry about which shard you deploy to and worry about only having composability with the other applications on your shard. With Shardeum, you just need to deploy your contract and you immediately have composability with all contracts on the network. So an example journey of a transaction in Shardeum is a user submits a transaction through a front end with their wallet. The front end injects EIP 2930, which is an access list of all the addresses involved in a transaction. That transaction hits the Shardeum RPC, which forwards the transaction to the network. And no matter which validator that transaction hits in Shardeum, every validator in Shardeum knows the addresses that all other validators in the network are assigned to, and it also knows the addresses involved in the transaction thanks to the access list under EIP 2930. Therefore, the validator can route that transaction immediately to the validators assigned to the addresses in that transaction. And those validators come together and form a consensus group where only the validators covering the addresses in that transaction vote on whether the transaction is accepted or rejected and come to a majority agreement or proof of quorum where they form a receipt showing there's more than 50% of agreement on accepting or rejecting that transaction. This allows Shardeum to retain atomic composability in one transaction where you can call numerous contracts on different shards simultaneously and come to consensus on the output of these contracts in one transaction. Some other reasons why developers are gravitating to Shardeum is because Shardeum has a focus on delivering users to applications. Shardeum Foundation would like the Shardeum network to be the first blockchain in the world where applications go mainstream and acquire billions of users thanks to our linear scaling and dynamic state sharding architecture. Today we have over 300,000 users on our testnet, and applications building on our testnet have been acquiring around 10 to 20,000 users on average within 1 to 2 weeks, which is really exciting. Shardeum is also the first EVM-based layer 1 that's native to India, being built by the community in India from the testnet phase. Every other layer 1 has been built outside of India and then tries to enter India. At Shardeum, we believe that India is the most important market in Web3 and is going to build more unicorns in Web3 than any other country. And so everyone in India is really excited to play a role in building Shardeum, and we're here to support you. Our co-founder Nishal Shetty is the founder of WazirX, India's largest exchange. And Nishal is also one of the top influencers in the Web3 ecosystem, as you likely know. Nishal has fought for positive regulation in India. For example, India went through a banking ban, and Nishal tweeted out #IndiaWantsCrypto for 1,000 days in a row, which helped motivate the government to end the banking ban. Nishal frequently has helped to educate and grow the Web3 community in India, and he's here today to support those of you who continue to build on Shardeum following this hackathon. Our co-founder Omar Syed has 30 years of experience building scalable distributed systems and is one of the most talented distributed systems engineers in the US. His second job in his career was at NASA, where in 1996, NASA took the first pictures of Mars, posted them on their website, became the most popular website in the world for a period of time. And Omar was one of the webmasters that had to scale NASA's website and their servers to handle that traffic. And so from the earliest days of the internet, Omar has been focused on scalability. This led to him being hired by Yahoo as their principal architect to re-architect the application they bought from Mark Cuban. It was a video streaming application that started crashing in 2006 when the US upgraded to broadband internet. Omar re-architected that application, and Yahoo is granted 4 patents on the system Omar designed for them. He's been working on the architecture for Shardis and Shardeum since 2016 and is here to support you today if you have any questions about scalability in Web3, distributed systems, or just generally want to talk about what you're building and get his guidance on the technology side of things. Shardeum is one of the fastest growing layer 1 communities in India and is the most active Web3 meetup organizer in India. Today we host 8 to 10 meetups per month in India across all major cities and some of the less populated cities as well. We've had over 1,600 attendees visit our meetups in the past 2.5 months. and over 3,000 people register for them. We're really excited that these are continuing to grow every month, and we're focused on scaling to 50 to 100 meetups per month across the world. We would love for you to continue building on Shardeum and help you create awareness for what you're building in our community. We'll invite you to attend all of our meetups, which you can see pictures of here. You can present what you're building to the community there, get feedback on what you're building, build partnerships, and become a leading application in the Shardeum ecosystem. Here you can see pictures of 16 meetups we've posted over the past few months, and we're really, really excited to watch this community continue to scale. So far this year, in just a few months, Shardeum has made great progress. We've raised an $18 million seed round. We're building really fast. We have 2 testnets live today. Our 3rd testnet will go live in December this quarter. We have 96,000 followers on Twitter who we can help ensure is aware of the products you're building on Shardeum. We have over 109,000 followers or members of our Discord channel. We can work with you on things like AMAs and promotions on Discord to help create awareness for what you're building and help you acquire thousands of users. Speaking of users, we have over 304,000 users on our testnet today, and we're just getting started. We're only in the testnet phase. This community growth has been all organic. We have around 9,600 contracts deployed at the time of this presentation on Shardeum, and we're excited to continue to scale. This is just the beginning. Thank you so much for listening to our presentation. During the hackathon today, to get started building on Shardeum, please visit our developer docs at docs.shardeum.org. And with that, I'd like to introduce Marcus Wentz, who will take you through the Shardeum demo.
Hi everyone, my name is Marcus Wentz. I'll be showing you how to connect to Shardeum. So there's a few different ways to connect Shardeum using MetaMask, which I have installed over here. We have MetaMask installed. Here are the RPC endpoint details that we would need to add. This is one way to do it. To get here, you'd have to go to the browser extension, hit add network. This window will pop up, and then you can add a network manually to add custom networks. And all the information that you need is here. So you would just fill all this information here, and then hit save, and then it would be recorded into MetaMask. So this is useful for DevNets, and we recommend you use Liberty 2.0 because it's sharded. So let's try out Liberty 2.0. We have 1.6 and 2.0 on chainlist.org. 1.6 is not sharded, 2.0 is sharded, but you'll need an access list, but we'll get to that later. Let's just double check that we have Liberty 2.0 installed. Awesome, we have Liberty 2.0 installed, as we can see here. So now that we're connected to Shardeum, now we need SHM tokens to pay for gas. So there's 2 ways to do this. We could either use a faucet website that we have here, or we could use a Discord faucet. For this workshop, we're going to be using the faucet website. So to use this, we'd have to make a tweet. I've copied the tweet to my clipboard, and now all I need to do is paste in that tweet. It'll have a null out address by default. I just copy and paste my address in so that the faucet can know where to send the tokens. I make the tweet. I'm going to refresh the page. Okay, now I'm going to grab the tweet and then just copy and paste the URL of this tweet here. Just going to close this out and close this other window that will open up. And then I would just paste in the tweet here. I already have SHM, so I'll get an error here. But if you didn't have any SHM, you would, after like a few seconds or like a minute or 2, you should get SHM deposited to the address that you tweet with that URL here. Okay, so now we have tokens. So now let's do a swap. Let's swap our SHM for wrapped SHM. So on this front end, it'll show wrapped Ether, but in reality, it's wrapped SHM on the Shardeum blockchain. We're going to swap 1 for 1. This should go to a 6, and this should go to a 7 down here. Get 7 wrapped ETH at the end, because we're getting 1. So the cool thing about Liberty 2.0 is, as mentioned earlier, it's sharded, and it uses cross-shard composability. And the way this works is you need to use an access list to communicate between the different shards for sending a transaction. But we'll get to that in a minute or two. So it looks like the transaction went through. It might take a few seconds for the balances to update. Awesome, the balance is updated. As expected, we have a 7 and we have a 6 at the balances here. Okay, now that we interacted with the contract on Shardeum, now let's actually deploy some new contracts to Shardeum. Here we have a hello world type contract where we're just going to store a value, a uint, here. And it's public, so we'll be able to easily view that function once it's recorded or at any point. To a set, we're actually changing the state. We set a uint, that will be the new value. I'm hitting Control S to compile the contract. By default, I'm in the virtual machine for Remix IDE. So to access any type of chain with MetaMask, we have to go to Injected Provider, MetaMask. Looks like it's connected. Now I'm going to hit Deploy. And now MetaMask is going to ask me to sign this transaction to confirm I want to deploy this contract to Shardeum. So it'll set this value and then record it to the storage slot. This is storage slot 0. And then it'll send out an event as well. Okay, awesome. The transaction went through. Since we didn't put a value, the default value will be 0 as expected. Let's change the value to, let's say, the number 1. And hit confirm. So when the transaction is finalized and accepted, this will go from a 0 to a 1 in the storage slot in the contract. Awesome. We have a 1 here. Now I'm going to show an example of an oracle. Here we have an oracle contract where we're able to get price feeds on chain. Let's just deploy this contract first. This is from Super Oracles. They offer price feeds for different cryptocurrencies on chain. So let's check out these functions. So with Bitcoin, when I click on this, I'll get the Bitcoin price relative to dollars or USDT. And then when I click on this ETH USDT, I'll get the price of ETH and USDT, because we're calling to this address and then we're saying, hey, if we want ETH and then we want Bitcoin, and then we could call these other functions somewhere else since we're returning the price, right? So here I'm just taking the value of Bitcoin over ETH. And as you can see, it could do the math for it. We also have, this is just the contract being recorded here for this contract instance. Awesome. Now let's jump to a more advanced contract. Here we have, this is very similar to this contract to the original contract where we're just changing the state and being able to see the state in the contract. However, this contract is actually able to call this contract here called multi-call, because it's able to grab the contract here and saying, oh, hey, I know this contract. And I'm saying, hey, here's the contract on this blockchain, and we're going to be able to interact with it and read and write to it. So here we're able to read slot 0, because this acts as like a view function. When you have it as public, it'll just return the value, which is very convenient. However, this will be a little trickier, but I'll get to this. First, I'm going to I already have this contract deployed on Liberty 2.0. I will just load it in to Remix IDE based off of its address. Just double check this is the right contract, the right data. This looks correct. Notice here the prefix is different for the address. So this is a B and this is a 0. On Shardeum, this means that they'll be on a different shard because their prefixes don't match. if we read, as we can see here, it's simple, right? This is the last Unix time that the state was changed, is what this is representing. However, if I try to change the value without adding an access list, the transaction will fail because the transaction won't know what shards to go to, since this is a multi-shard transaction. So we should get a fail transaction in the next second or two. Fail transaction as expected. So let's pay attention to this value here. It ends in 502. We have a script here where we have an access list. The way this is structured is we have the other contract we're going to interact with, and then we have its storage slot, and then a code hash here for that address. Now what I'm going to do is I'm going to run the script. And this is the previous value. This is the current time. Let's see the value updated. As expected, the value updated because we sent this transaction with the access list. So awesome, it's working. To give another example of when you would need the access list, let's think of it in terms of tokens. Let's say we have an ERC20 token. With total supply, it's just a view function. We're just trying to see how many tokens exist. So we're not changing the state of that contract. We don't need to pay gas or change storage slots. We're just reading. However, if we want to transfer tokens, say like we have tokens and we want to give them to someone else, this will change the state of that contract, and we'll need to pay gas and interact with store slots. So this will actually require the access list because it'll need that access list to render what shards to interact with. But we preload this information in with the reading. So the good thing about this is we're actually able to automate the access list with an RPC. The way this is structured is we have an address and an ABI. So this is how we define our contract. It's the contract instance, and then we have the method that we're going to call from that contract. What you could also do for this method as well is you can put in an input argument if that function needs it, but this function doesn't have any input argument, so it's just blank. And with that, we have an unsigned transaction. And with that unsigned transaction, we could call this RPC, which will generate the access list for us automatically. We don't have to compute it. All we need to do is just send the transaction and say, hey, we have a type 1 transaction that will include the access list, and we just grab the access list from here and put it in the transaction, and that's all we need to do. It's very simple. You would use ethers.js to access this. This is the simplest way to access the RPC. So here we have an interface. Interfaces are very useful for interacting with old contracts. Wrapped Ether, wrapped SHM, they're Solidity 0.4, and they don't support safe math by default. When you build a new contract without safe math, you can have underflows and overflows, which could be security risks for a contract. That's typically why most developers develop with 0.8 now. And to interact with this contract, we'll abstractly define all these other functions, or the functions that we just need. We just need a few functions for this example. So we could abstractly call them in this interface. And we say, hey, these are the functions we want to call based off of their names and their input arguments and what they're returning. And then point at the address where that contract is deployed, and it's as simple as that. You will need the access list for contracts like this because it's at a different contract, therefore it'll be at a different shard unless you get lucky with the same prefix. It was a brief intro into Shardeum. Hope you all enjoyed. Would love to see everyone check out the Shardeum Discord as well. Thank you for watching.